Welcome back, everyone. DevDays Europe, the third session today, and we have an awesome speaker with me, Dmitrii Ivashchenko. Hi, how are you doing?
Hello, everyone. Hi, I'm doing well. And you?
Yeah, I'm also doing fine. Thank you. So I'm your host, Fern Rappel, and in this session, we are going to take Python or asynchronous Python to be more specific to the next level. So tell us what is awaiting us in this awesome session.
Yeah, today we'll compare two libraries, Trio and Asynchronous, and we will delve into the Trio structured concurrency. It's a more unique approach to make your code even better, your asynchronous code, more streamlined and reliable.
Awesome. Can't wait for it. And with that, the stage is all yours. Thanks.
Thank you. Okay, so hello everyone once again. I'm Dmitrii Ivashchenko from My.Games. And today we are diving deep into Trio, groundbreaking library for async programming. So it's not just a cool, it changes how we handle synchronous operations in Python, and we'll break down how it uses a well-structured concurrency model to manage tasks effectively. And this model simplifies task management, making your project more maintainable and less error-prone. And I'll guide you through several practices. So let's get started. Let's delve into the mechanics of how Trio operates. We'll start by exploring the concept of structured concurrency, cornerstone of Trio's design. This approach is not only cleans up your code, but makes it more easier to follow and manage, to fine-tune it. And we'll thoroughly examine how Trio manages timeouts and cancellations. Next, we'll discuss how Trio ensures smooth synchronizations of tasks and optimal management of IO operations. We'll also compare Trio's features directly to Asynchronous, highlighting why Trio might be a better choice in many scenarios. And in addition to core features, we'll delve into Trio Asynchronous library. It's ideal for environments that utilize both systems. And finally, we'll discuss the latest updates of Trio. So let's start by delving deep into core features of Trio. And Trio design focuses on simplicity and robustness in handling current tasks. And these core features provide a solid foundation for building reliable and scalable applications. So the first concept we will tackle is nurseries and spawning within the Trio. Nurseries and spawning are essential for managing multiple synchronous tasks effectively. These features are central to Trio's design, promoting a structured way to handle concurrency. They ensure that tasks within a nursery are managed from start to finish in a controlled environment. In Trio, using nurseries involves a straightforward syntax with the async with statement. First, you initiate a nursery by calling open nursery function. Within the nursery context, you can easily spawn tasks using nursery.startSoon method. And this example illustrates a basic parent-child task relationship management within the nursery. The child tasks run concurrently, demonstrating Trio's efficiency in managing multiple tasks. And this setup ensures that all child tasks complete before the nursery exits. So considering the syntax, let's apply it to a practical scenario, like managing multiple web requests. In this setup, each web request is handled as an independent task within the nursery. And the nursery starts these tasks almost simultaneously. And this method is particularly effective for web applications that require high responsiveness. It ensures all tasks are completed before the program proceeds. So moving on from nurseries, let's delve into another crucial feature of Trio, checkpoints. Checkpoints are vital for effectively managing transitions between tasks in Trio. They serve two main purposes. They check for task cancellation and enable task switching. This dial functionality ensures that asynchronous applications remain responsive and robust, and by integrating checkpoints, Trio fosters cooperative multitasking environments, and it's enhancing overall system efficiency. So checkpoints occur at every async operation that might block, such as, for example, await trio sleep 1 in this example. Each checkpoint gives trio an opportunity to perform essential maintenance tasks like checking for cancellations or switching. It also allows trio scheduler to decide whether it's time to switch tasks. Yeah. To better understand this, let's examine how checkpoint operate within a live trio environment. And consider an application that handles multiple database queries simultaneously. Using checkpoints allows each query to be processed concurrently, enhancing system throughput. And this concurrent processing minimizes response times and maximizes efficiency across all the application. For instance, while one query waits for data, another can progress, making the most available system resources. And proper use of checkpoints ensures that no single tasks monopolizes the system resources. Yeah, it's promoting equal resource allocation across all the tasks. Moving on, let's focus on how Trio effectively handles error management. And in complex applications, it's common for multiple tasks to fail simultaneously. And when this happens, multiple exceptions can be thrown at the same time, and it's complicating error handling. And Trio uses the exception group to encapsulate all these exceptions together. And this model is highly efficient. It's allowing developers to handle several exceptions in one go. So let's delve into this mechanic. Trio supports except syntax for handling exception groups, introduced in Python 3.11. And this feature allows each type of exception within the exception group to be managed separately. Such precise control is vital in environments where multiple tasks run concurrently, and let's explore how this syntax can be used to streamline error handling in your project. Imagine a scenario managing file operations where errors are most likely. In such cases, Trio's error handling capabilities come to the forefront and managing read and write errors effectively. When errors occur, they are grouped together in an exception group. This model enables handling errors from multiple operations in a unified manner. Okay, let's discuss timeouts at Trio, switching gears a bit. Timeouts are crucial for controlling how long a code segment can run before it needs to be canceled. They are implemented using cancel scopes, which provide a clean, manageable way to handle timing. And this setup ensures that operations are not allowed to run indefinitely. Yeah, using timeouts actually can prevent tasks from consuming more time than allocated, enhancing overall system efficiency. So let's explore how cancel scope works and how they can be applied. Here's how you can practically implement these timeouts to keep your operations moving efficient. Trio move on after function is exactly for this purpose. It's essential for setting timeouts for specific code blocks. And if the operation within the block exceed the specified time, Trio automatically cancels them. This cancellation is executed by raising a canceled exception. And this method is straightforward, but it's also very powerful for maintaining control over tasks and execution times. Imagine you are managing a high traffic web server that must handle a large volume of requests efficiently, and setting strategic timeouts it can ensure that no single request can slow down the server's operations. Yeah. In our example, a 5-second timeout is applied to each request to maintain high responsiveness. And if a request cannot be processed within the time frame, the server issues a timeout message. So this practice not only improves server reliability, but also enhances its responsiveness to user requests, right? Now let's pivot to another critical feature, cancellation. Cancellation is a key mechanism in Trio that allows explicit stopping of tasks, whatever manually or due to timeouts. It uses a well-structured approach to effectively handle interruptions in task execution. This feature is integrated in Trio model of concurrent programming, and it's enhancing control over task lifecycles. Cancellation gives developers comprehensive control over stopping asynchronous operation whenever necessary, and it ensures that system resources are not wasted on tasks that no longer need to continue. So how they'll appear and how we can implement cancellations within your tasks for more precise control. Trio utilizes function move on after to set timeout, time-bound limits on tasks and enabling automatic cancellations. Yeah, if a task doesn't complete within the set timeout, Trio raises a cancelled exception, as we said before, and this exception is crucial as it unwinds the execution step. Yeah, it's allowing tasks to be stopped cleanly and safely, and developers need to properly handle this exception to ensure that all resources are correctly cleaned up. So for a practical example, consider managing database transactions with strategic use of cancellation. Setting timeouts is crucial for ensuring that transactions do not affect application performance. In our scenario, a database query is configured with 3-second timeouts to ensure rapid operation. And if the query takes longer than this allowed time, the transaction is automatically canceled by Trio. So implementing such cancellations helps maintain the stability and responsiveness of the application. And moving on, let's examine how Trio facilitates task communication and synchronization. And effective synchronization is crucial for maintaining order and consistency in asynchronous applications. And Trio offers robust tools for task synchronization, crucial for managing shared state. Let's break it down. And the prime example of synchronization in Trio is the semaphore. Yeah, semaphores, they are used to manage access among concurrent tasks in some controlled manner, yeah. And by acquiring semaphore, a task gains exclusive access to certain resources, yeah, preventing some other conflicts. This pattern is essential for avoiding race conditions and ensuring task executed in right sequence. And Trio semaphore are designed to be fair and allocating access based on the order requests are made. And by mastering the patterns, you can significantly enhance the robustness of your application. So another key pattern in Trio synchronization toolkit is producer-consumer model. Yeah, this model uses channels to facilitate smooth and secure communication between tasks. A producer task sends a message through a channel. The message are then received by a consumer task, and channels ensure that data is transferred safely and efficiently. It's maintaining proper sequence and flow control, and consumer processes each message one by one in direct order, ensuring that no data is lost or mishandled. Yeah, and using channels in Trio helps to maintain the clear separation of concerns and enhances that data integrity. So speaking of channels, let's shift our focus to another core feature in Trio, stream handling. Trio's IO capability are centered around a comprehensive stream API for handling byte streams. And this API simplifies the creation of flexible and robust protocol implementations. And by abstracting stream interfaces, Trio supports a wide range of data transport mechanisms. And this flexibility allows developers to handle data streams in a uniform and efficient manner. So let's delve deeper in how this API works. For instance, setting up secure connections is something much straightforward with the Trio's SSL stream. And we use an SSL stream wrapped around a basic socket stream to secure communications. This setup involves establishing an SSL connection over a standard TCP socket, and SSL stream simplifies encryption by making the transport layer interchangeable and secure. This streamlined approach enables developers to adapt existing network code for secure communications almost effortlessly, as you can see. So Drew also offers strong support for asynchronous file system I/O, enhancing applications responsiveness. And the example we'll explore involves reading a file asynchronously using Trio's path object. Asynchronous file operation prevent I/O tasks from blocking the main execution thread, and this non-blocking approach significantly reduces latency in I/O-intensive applications. So it allows for smoother task and better utilization of system resources. So, having seen all these features, let's compare Trio with Asyncio to understand their differences. Both frameworks provide a powerful tool for asynchronous programming, but differ in their code philosophies and implementations. Trio's design emphasizes simplicity and safety, which can be seen in its structured approach to concurrency. And Asyncio, on the other hand, offers a more traditional event-driven model that prioritizes flexibility and scale. Yeah. So let's explore how these differences affect code clarity, error handling, and overall system scalability. The first notable difference is, of course, structured concurrency model, used by Trio. And Trio model organizes tasks into nurseries, it enhances code readability and row containment. The structure ensures that tasks are explicitly scoped and managed. And it's leading to a safer and more maintainable code in the end. In contrast, Asyncio relies on an event loop and futures to handle tasks, offering greater flexibility, but at the cost of complexity. And these differences can significantly influence how developers approach task management and error handling. The structured nature of Trio can reduce bugs and simplify debugging process, but Asyncio's flexibility can leverage in highly dynamic environments. So in Trio, asynchronous tasks are carefully managed within nurseries, and it's providing clear and explicit scoping. This arrangement highlights the hierarchical nature of task dependencies. That's a benefit. And it's making the system behavior more predictable. In contrast, Asyncio uses an event loop where tasks are managed more loosely through futures and callbacks. And this example shows how each model handles task management, including everything from error handling to resource allocation. Let's consider a web application designed to handle multiple simultaneous requests effectively. And in Trio, each request is managed as a separate task within a nursery. It's ensuring structured and orderly task competition. And this method provides a clean lifecycle for each task. Tasks terminating clearly when no longer needed. And in contrast, Asyncio handles each request as a separate task, but without the explicit structure provided by nurseries. This difference can affect how resources are managed and how tasks are terminated, impacting system performance and reliability, maybe. So now let's look at how Trio and Asyncio handles errors differently. Both frameworks provide mechanisms for error management in asynchronous environments, but the approach is uniquely. Trio integrates error handling seamlessly into its structured concurrency model, emphasizing clarity and predictability, of course. This integration ensures errors are managed consistently and logically, and it's reducing the chance of unhandled exceptions. Asyncio, while robust, requires more attention to effectively manage errors due to its complex nature. Let's see how these error handling models affect application scalability and developer overheat. Trio uses nurseries to encapsulate tasks and ensure errors are contained within the structured blocks. In our Trio example, the nursery acts as a safeguard. It's catching and escalating errors from child tasks to the parent task. And this model allows errors to be handled predictably, enhancing code readability and safety. Asynchronous, on the other hand, requires tasks to be explicitly awaited and errors to be carefully handled. This can lead to challenges in error management, especially if exceptions are not handled properly. Yeah? So we'll examine how this explicit error propagation in Trio simplifies debugging and error tracking. As you can see, structured error handling in Trio can reduce the complexity sometimes. Now let's consider a web application that needs robust error management for database queries, for example. In Trio, the structured model ensures that any errors in data fetching are properly handled within the defined scope. And this model leads to more cleaner, more systematic error management, making the system maybe a little bit easier to maintain. Yeah. In contrast, Asynchronous handles error on per task basis. Yeah, one by one, and it's requiring individual task tracking and handle for each possible exception. And this approach is flexible, but can complicate error management, especially in maybe more larger, more complex systems. And Trio structured approach can lead to more maintainable, predictable error handling. And on the other hand, the Asynchronous method requires careful setup to avoid potential pitfalls on error propagation. So it's quite a bit important of understanding what this difference can help you design better error handling strategies in your applications. So let's explore the distinct design philosophies behind Trio and Asynchronous. Trio is designed to simplify asynchronous programming through comprehensive high-level abstractions. And its philosophy is to make asynchronous code as straightforward and error-free as it possible. Asynchronous, conversely, offers a wide spectrum of APIs ranging from low-level to high-level. And this variety provides a greater flexibility, but introduces some complexity and maybe a bit longer learning curve. Yeah. This different philosophies impact usability, maintenance, and scalability of your projects. So Trio's API aims to get rid of many low-level details to streamline the development process. And provide a Trio example, the nursery context manager handles tasks concurrently with minimal overhead. And this approach reduces boilerplate code and focuses on enhancing ease of use. Asynchronous, on the other hand, offers granular low-level API and high-level stream abstractions. While Asynchronous flexibility is advantage, it requires developers to manage some small details. Simplification in Trio can lead to faster development times, but may limit fine control. Conversely, Asynchronous flexibility in handling detailed operations allows for more customized solution at the cost of simplicity, of course. And let's explore the practical impacts of these API choices through an example of network communication. This example illustrates implementing a basic chat server, simple, using both Trio and Asynchronous. With Trio, the abstraction layer allows developers to focus on the core logic without delving into details of asynchronous management. And this simplicity aids in quick development and reduces its potential for bug related to task handling. Asynchronous model offers flexibility to control every aspect, and This can be beneficial for optimizing performance and customizing behavior for specific needs. So next problem is integration with existing code. And integrating asynchronous frameworks into existing systems can be challenging, of course, and Trio's requirement for significant adaptation stems from its structured concurrency model. To integrate Trio effectively, legacy synchronous code must be restructured, and we need to utilize nurseries for task management. So this shift is to structured concurrency can dramatically change sometimes how tasks are created, managed, and synchronized. While this can enhance safety and maintainability, it requires considerable effort to understanding and restructuring your projects. On the other hand, Asynchronous integration is often smoother due to its flexible event loop and task model. So Asynchronous allows for incremental adoption, where only parts of the system need to be asynchronous. And this flexibility makes Asynchronous appealing for projects that need gradual integration without complete overhauls. But actually, you can also combine these two libraries together. And we have Trio Asynchronous. It's a pivotal library that bridges the structured concurrency of Trio with asynchronous flexibility. This library is designed to allow developers to use strength of Trio and Asynchronous within the same application. And using Trio Asynchronous, projects can benefit from Trio's structured approach and broad capability of asynchronous libraries. This integration facilitates a smoother transition for projects requiring features from both frameworks. The library provides a unique opportunity to experiment with both frameworks without committing to one or the other. So let's look at it. This library offers valuable tools like Trio as AIO and AIO as Trio. You can seamlessly convert function calls between Trio and Asynchronous. And this tool enables functions written for one framework to operate within the context of the other framework. And so this flexibility allows developers to maintain existing code in one style while experimenting with other. And by using Trio Asynchronous, application can leverage the benefits of both libraries without extensive refactoring. And this capability is especially useful in mixed environments where certain tasks are better suited to one model over the other, and you can choose. Next slide. Let's look at latest updates for 2023 and 2024 of Trio library. And all these recent developments have focused on improving scalability, on error handling, and integration with other systems. We'll explore key new features that have been developed based on community feedback and some evolving programming practices. The first one is thread completion wait. Thread completion wait is a crucial new feature designed to ensure that shutdowns are clear in multi-threaded environments. And this feature enhances Trio's ability to handle asynchronous programming alongside traditional multi-threading. It ensures that all threads have completed their task before the main are concluded. And this addition is particularly useful in environments where concurrent operations depend on tasks that must be carefully synchronized. So thread completion wait provides a more reliable method for shutting down systems without losing data. By ensuring that no threads are left running, it prevents resource leakage and ensure all tasks are cleanly wrapped up before shutdown. And this feature is a significant step toward making Trio a safer framework for complex asynchronous applications. Wait for thread completion is crucial in systems where clear shutdowns are necessary to prevent issues. And it introduces the function wait all threads completed it is designed exactly for this purpose. It blocks that task execution until all threads spawned during trio operations have completed. It's ensuring a correct shutdown process, and this function is especially useful in server environments where multiple clients connections can carefully managed. And using this function in multi-threaded server scenario helps manage client connection more reliable. After the server main loop exits, this method ensures that all client connections are properly closed. And this prevents the server from accidentally shutting down while background tasks are still in progress, which could lead to resource leaks and some data corruptions. So as we can see its importance in maintaining the integrity of the network-based applications. Two recent adoptions of the Pathlib library enhances its file system interaction capabilities. Integrating pathlibs aligns Trio with Python's standard tools for path manipulation. It's making file operation more intuitive. And this feature enables developers to perform file and directory operations within some asynchronous environment seamlessly, almost. And by leveraging Pathlib, Trio offers a more Pythonic approach to asynchronous file management. So this integration simplifies the transition for developers new to asynchronous programming by using well-known patterns. We'll explore how these changes make file operations easier to implement and more efficient. Trio Path object is now fully integrated with Pathlib Pure Path object. It's offering a unified interface for file path operations, and this change enables natural integration with other Pathlib types, enhancing Trio usability. Methods like itdir and readText have to support Trio's asynchronous operations, and it's making them non-blocking. Yeah. This example on the left demonstrates how we can asynchronously read directory context using Trio's enhanced path interface. And this operation allows developers to handle file system tasks using familiar and intuitive Pathlib patterns. Consider the scenario on the right, which involves managing numerous files across different directories. And using Trio's path, operations like copying and moving files are handled almost asynchronously, and enhancing efficiency and fair system resource allocation. The method globe is used to identify specific files, and they will be copied to a backup location asynchronously. This integration not only makes file operations not blocking, but also more reliable and easier to manage in concurrent environments. Trio version 0.24 introduces new testing helpers designed to streamline the testing of exception handling. These helpers are particularly useful for testing exception groups we've spoken earlier. And the integration of these tools reflects Trio's commitment to making robust and effective testing more accessible. So let's look at it. The new testing helpers, Raises group and Mature, both are crucial for effective managing Trio's exception groups during testing. Raises group allows developers to specify their expect multiple exceptions within a single test scenario. And Mature is used to assert specific details about exception within an exception group, such as types or messages. And this combination provides a powerful tool set for precisely verifying the behavior of code under some specific error conditions. This example here demonstrates how we can use a network application to handle tasks multiple types simultaneously. Yeah? And by using Raises group and Matures, developers can create more detailed and robust tests for a system that handle complex error scenarios. These tools ensure that all expected exceptions are correctly handled and their properties match their expected conditions predefined. Trio's latest updates enhances its type checking capabilities to prevent common bugs in asynchronous code. Yes, and the new enhanced type checking feature utilizes type or tuple. It's improving flexibility and safety of type annotations in many Trio functions. This update is designed to help developers catch type-related errors early, significantly reducing runtime issues. And enhanced type checking is especially valuable in dynamic environments where type mismatches can lead to complex bugs. So by implementing more strict type checks, Trio helps ensure that functions are used with correct types, enhancing overall code safety. Let's examine the exception types. The incorporation of type or tuple into Trio's type system allows for more sophisticated type checks across asynchronous functions. This feature enables Trio to perform checks on variable argument lists, ensuring that all passed arguments match expected types. And by enhancing type safety, Trio makes it easier for the developer to catch and fix all the type-related errors during the development process before the runtime. Consider the implementation of a type-safe asynchronous database query handler, where each parameter's types is validated against expected type. This type safety ensures that the function handling of query and its parameters are correctly typed. And using these type checks, developers can enforce stricter type constraints, which can lead to more reliable and more error-resistant code. The next one is nursery exit behavior. Trio 0.23 introduces improvements in nursery exit behavior, and this update enhances reliability of asynchronous tasks within nurseries. And when exiting a nursery, Trio ensures that the parent task waits for all child tasks for completion correctly. And this behavior guarantees that no tasks are left hanging, which could lead to some data loss or maybe corrupt state. And this enhancement is crucial for application requiring robust task synchronization and precise control over task execution, control of task competitions. Yeah. So let's examine the impact of these improvements. The update to nursery exit behavior ensures that parent tasks reliably wait for all child tasks before exiting. The synchronization enhancement prevents the early termination of parent tasks, which was a common issue in previous versions. Previously, if child tasks were still running, an early exit could disrupt the workflow and lead to mismatches. So the improved behavior includes handling of cancellation attempts more elegantly, and it's avoiding the injection of canceled exceptions. Consider a scenario where an application manages multiple concurrent database queries. With the updated behavior, all queries must complete before the system process and data processing. And it's ensuring data consistency and integrity. So this ensures smoother operations and more reliable data handling, particularly in applications where timing and order of operations have some importance for us. The next feature, thread and task integration. Trio 0.23 also brings significant improvements to how threads and tasks interact, and it's enhancing concurrency management. These updates ensure that better context and cancellation propagation between threads and Trio's main event loop. Yeah. Improvements focus on making task execution within threads more predictable and more reliable. And let's explore specific examples. This approach to thread integration focuses on making task context and state during transitions. Let's look at run sync function. This function is crucial. It's enabling synchronous functions to run in separate threads without blocking the main event loop. This capability is especially useful in applications like web scrapers that need to perform multiple synchronous operations concurrently. Using runsync, developers can handle synchronous operations in a non-blocking manner, such as making HTTP requests, for example, simultaneously. This method allows the trio events loop to continue managing the other synchronous tasks effectively. It's great optimizing overall application performance. And consider a synchronous web scraper designed to fetch data from multiple URLs simultaneously. By executing HTTP requests in separate threads, the main asynchronous flow remains unblocked and more responsive for our purpose. This setup not only enhances performance, but also improves the scalability of the application. And as you can see, the next one. The same version, Trio 0.23, introduces refined capabilities in guest run initialization. It's enhancing how we handle external integrations with some other libraries. This update allows developers to immediately utilize Trio-specific operations once initialization is complete. So guest run initialization is particularly useful for applications that require integration with some non-asynchronous libraries. This feature ensures that Trio's asynchronous environment is ready to handle tasks as soon as setup is complete. So by providing smoother transitions between synchronous and asynchronous code, Trio opens up more possibilities for diverse application architectures. We'll explore how this initialization can facilitate the use of Trio in systems where external libraries play a crucial role. And let's see it. So Trio's enhanced guest run initialization now includes more setup organization before returning control to the main program. It does a bit more job for us. This change allows for immediate use of Trio-specific APIs right after initialization. Consider a scenario where asynchronous database operation need to be integrated and make it seamlessly and with some external library. With the refined guest run initialization, Trio can manage asynchronous tasks alongside operations initiated by external libraries. This functionality is crucial for applications that depend on external systems for data operations, but want to maintain asynchronous effectively. Yeah? Guest run initialization not only streamlines interactions with external libraries, but also enhances the robustness of this integration by ensuring that Trio's environment is fully operational immediately after setup. Developers can avoid common pitfalls associated with asynchronous integrations. Yeah, Trio 22 introduces the capability to name threads created with runsync function. We can specify the name and send it to parameter to runsync. So we've learned a lot about Trio through this presentation. As we move to summarize, let's recall the key takeaways from the discussion. Trio makes handling multiple tasks simultaneously easier and safe thanks to its structured concurrency. And we started by exploring how nurseries provide safer space for task execution and examine Trio's robust error handling mechanisms. We discussed checkpoints and timeouts, semaphores, memory channels, and also compared Trio with Asynchronous. These are updates from Pairflip integration to advanced type checking, equip developers with powerful tool to tackle modern asynchronous programming challenges. So finally, I just want to say thank you for your attention today, and thanks to DevDays for hosting this session. Hope you found the discussion informative and maybe provided you with valuable insights to using Trio for your projects. So yeah, if you have any questions, feel free to ask now or contact me later. And look forward to seeing you at future events or collaborating on some open source projects maybe. Thank you.
Awesome. Thanks a lot. So we are unfortunately a little bit over time. Therefore, maybe just one last question. Are there any reasons for not using the Trio, for instance, over Async.io?
Trio is not designed to be much more boost of performance in your application. It is designed for simplify your development, and it can boost the speed of your development process, but it's not designed to make any performance. If you need extremely fast, make it in C or C++, yeah.
All right. Wonderful. Then thanks again for the nice session, and everyone else, enjoy the conference. Next talk's up in a couple of minutes. Bye.
Thank you. Bye.